crazy similar to what we did on Thursday, because what we did on Thursday was like a review, and then I added an extra step. That extra step that I added is technically today's lesson. So today's going to feel very repetitive, but that's why we're going to hopefully be able to kind of zoom through it. We'll do most of the stuff we did on Thursday, plus like one additional thing that we'll get to at the very, very end, okay? But in general, today we are solving or finding the zeros of higher order polynomials, so of stuff that has something greater than an x squared. What we did on Thursday was we said, okay, we can either factor these, or if we're given a factor, we can use synthetic division to kind of bump it down a level and then factor from there. We're doing the same thing today, just a little bit different eventually. But for this first one, if we wanted to factor it, first step to factor anything, what should I do?
GCF.
GCF, what's my GCF?
X.
X. Take out an X. We cannot divide off that X because we'd be dividing by something that we don't know what it is yet. Okay, so we have to keep it here on the outside as a GCF. We're left with 2x squared plus x minus 28. Hi, Peter. Now I have something with 3 terms. How do I factor a trinomial? Try the x method. Okay. So 2 numbers that multiply to, what's 2 times negative 28? Negative 56. And add to my middle number, 1. What do we think? I heard 8. 8's a good number. And negative 7. Perfect. Can I just put these right back in as factors and say x minus 7, x plus 8? Why not? Yeah, because a is not 1. Okay? So we have to rewrite our middle term. 2x squared. I'm going to write the 8x first, just because I noticed right off the bat they're both even, the 2 and the 8. Minus 7x minus 28. Still equal to 0. My x I'm done with that GCF that I took out. Now I have 4 terms. How do I factor something with 4 terms? Grouping. So I group my first 2, my second 2. The negative stays with my second one, and I exchange it for a plus sign in between. Okay. We can't lose our GCF, so that's going to hang out with us. From my first group, what can I pull out? 2x. And I would be left with x plus 4. From my second group, I need to take out something to be left with x plus 4. Negative 7. Okay. My GCF in the front stays. My matching parentheses are part of my factors, so the x plus 4. And those GCFs that I pulled out, so the 2x minus 7. That's technically all stuff from Unit 2. We could have factored this in Unit 2. The new part is setting it equal to 0. What should I do with each of these factors now to solve? Set them each equal to 0. So pay attention here because it's a little tricky. This first one is a factor. It doesn't look like it, but that's technically the factor x plus 0. So I can still set it equal to 0. So that's one of my solutions. X is equal to 0. And I think I mentioned this before, but that's why we can't just divide off those GCFs if they have a variable, because we'd technically be dividing by 0, which we can't do in math. If I set x plus 4 equal to 0, what do I get? Negative 4. And then if I set 2x minus 7 is equal to 0, I add my 7. Divide by 2, we get 7 over 2. I got you another one. What do we notice about the number of solutions that I have and the exponent?
There's 3 in there.
Yeah, they're the same. That will always happen. unless one of these is like repeated. So I could have had like x equals 0, and 7/2, and that still would count as 3. Okay? So that should always happen. Your exponent should match the number of solutions that you have. Okay. The next one, I'm going to reword this a little bit. Instead of factor, we're going to say solve the equation. If my pen will work. Solve the equation when it's set equal to 0. Okay? So this more leans into stuff that technically we're doing today, but I introduced it last week. They tell us that x plus 2 is a factor. So what is one of my zeros, my special number that goes in the box? -2. We set this equal to 0 and we solve for x. So -2 is my special number. I line up my coefficients on the top. 3, -4, -28, and -16. Then I drop the baby mama with multiplication and addition. So we drop the 3 times -2 is -6. Plus -4 is -10. We get +20. Keep going, Brooke. -8. +16. 0. We knew that this last piece was going to be 0 because they told us that x plus 2 is a factor. If you do not get 0, you back up, you try again. Okay? Now, our original equation turned into what we divided by, that factor, so x plus 2, times what we got after we divided it off. What is the degree of this polynomial? I started with an x cubed. What's down here? X squared. So 3x squared minus 10x minus 8. Okay. The x plus 2 is handled. This one is 3 terms. What method should I try first? X method. Okay, 2 numbers that multiply to -24. That's 3 times -8. And add to -10. Not quite. That would get you a +24, -6, and -4. I heard, yeah, go ahead, Seamus.
-12.
Very good. -12, +2. This one again, A is not 1, so I can't just write x minus 12x plus 2. I have to regroup my trinomial. So I'm going to rewrite my middle term as minus 12x plus 2x. Now I have 4 terms. I can group. What would I take out of my first group? 3x. Okay. I'm going to kind of do a shortcut here. This is what I'm taking out of my first group. What am I going to be left with? X minus 4. So I know that's going to be my matching parenthesis. And then what should I take out of this second piece? 2. So 3x plus 2. Did a little shortcut. Didn't actually show that pulling out the GCF part. But this is what we would get after we factor. Now that it's factored, what should I do with each of those pairs of parentheses? We don't want to FOIL because that would get us back to what we started with. Set them equal to 0. Anytime you have a bunch of things multiplied together, set them equal to 0. So for this first one, what solution would this give me? -2. Okay. This one, if I subtract the 2 and divide by 3, -2 over 3, and then +4. Again, just double check. 1, 2, 3 solutions, and the exponent that we started with was 3. Questions on either of those? We're going to do the exact same thing today. Factoring to solve, using synthetic division to solve, and then we're going to add one other piece to it. Okay? Just a few reminders. because I promise you one of you will mess this up on your test. But if you are given a factor that is x minus a number, you have to change the sign to put it into your special box or to write your solutions. So if x minus 1 is a factor, then x equals 1 is your special number and your solution. So we call our special number our solutions. They're also zeros, they're roots, they're solutions. And the new part that we're going to talk about today is that if that number is a real number, there also are x-intercepts. And we can see them on the graph because it's where our graph will cross the x-axis. So if they're real numbers, there also are x-intercepts. It also means that if we plug that number into our equation, so we find f of k, we plug k in to our equation, we get 0 back. That's what a 0 is. You plug it in, and y is 0. Something else that I mentioned on Thursday, probably during homework time, but it's going to come up more today. If your solution is a fraction, because we will be working backwards a little bit from solutions to factors. So if your solution is a fraction, to write it as a factor, does anyone remember what we do? It's x times your denominator minus your numerator. So we'll do an example, but we are going to be working backwards a little bit today, switching a lot between solutions and factors. So if, for example, x is equal to 2/3, its factor, it would be x times your denominator, so x times 3, 3x, minus your numerator, minus 2. Yes?
The denominator is the one lower.
On the bottom, yeah. Denominator's bottom, numerator's top. Okay. So this is how we're going to write all of our solutions in as factors if they're fractions. I'll show you another way to do it too, but it kind of goes against what I taught you earlier in the year. So this is how I want us to really try to do it. Or else the stuff that I taught you earlier in the year is going to get mixed up. But we'll do an example of both ways. Questions on this box and switching all of those signs? Okay. We have 3 examples where we just straight up factor and solve. So this first one, I'm making a mental note immediately that this isn't x to the 4th. But it's still 3 terms. What method can I use? X method. Multiply to negative 72. Add to negative 1. Everyone struggled with this all day.
8.
Very good. 8 and 9. Which one's negative?
8.
9. Negative 9. Because we have to add a negative 1. Okay. A is 1. So can I just say x minus, or x plus 8, x minus 9? Why not? Because our exponent's not 2. So I can't just say x minus, or x plus 8, x minus 9, because that would only get me an x squared. I need an x to the 4th. So if you remember, that's when we start with our x squared instead of our x. We take that exponent and we divide it by 2. If you don't remember that, we could also rewrite our middle term and regroup. Same thing. But x squared plus 8 and x squared minus 9. We can also regroup and you'll get the same thing. Am I done factoring these two? Which one still needs work? The minus 9. Seamus, what does it turn into? X plus 3 and x minus 3, because we can take the square root of each, do a difference of squares on x and 3. So x plus 3, x minus 3. Now everything's factored. What should I do to each factor? What we always do, set them equal to 0. So from the right-hand side, we would get 3 and -3. Just switch your signs. On the left, x squared plus 8, I'm going to subtract the 8 over. So x squared is equal to -8. Now what? Not quite. Square root both sides. Okay. So x is equal to plus or minus the square root of -8. Go ahead.
Can we pull out an I to make it
Yeah, we definitely want to pull out an I. We can actually pull out a little bit more than that. What perfect square factor fits into 8? 4. So I'm going to rewrite it as the square root of -4 times the square root of 2.
Would we lose points if we forget to take out the I?
Yes. What's the square root of -4? 2i. So we get 2i root 2. And that accounts for 2 of my solutions. My 3 and my -3 are my other 2. So 4 total. Yeah.
Would you be okay if we just wrote it as x equals plus or minus 3?
Sure. Perfect. Any other questions? Because yeah, technically here you don't even have to do a difference of squares. You could just set this equal to 0, add the 9, take the square root. But yeah, plus or minus 3 is good. Any other questions? Okay, let's do another one. This one, again, higher order because it's an x cubed. But I only have 2 terms, so I'm looking for something special. I'm looking for cubes or squares. Which one do I have? Cubes. So I'm going to take the cube root of each. What's the cube root of x cubed? X. Cube root of 8? 2. For my cubes, I had a set of small and big parentheses. Let's do my signs first. What acronym do I use for my signs? SOAP. Same sign, opposite sign, always positive. So this is a difference of cubes. In my first pair of parentheses, what should I do? What goes there? Yeah, those 2 cube roots that I got. So x minus 2. Then I square both of them and put them in the first and the last spot. So x squared and then 2 squared is 4. 2x in the middle. Perfect. Okay. Can I continue factoring this?
Yes.
No, why not, Brooke? You're right. Yeah, because I told you this last piece, this trinomial, will never be able to factor. But I still have to set both of these equal to 0. So x minus 2 is equal to 0. There's one of my solutions as positive 2. This one's going to get me my other 2 solutions. X squared plus 2x plus 4 is equal to 0. This is what we did last unit, solving quadratics. We had 4 options last unit. Option 1 was factoring. I already told you we can't do that. Option 2 was square root method. We can't do that here because of this term. What were my other 2 options?
Completing the square and quadratic formula.
Perfect. Complete the square or quadratic formula. Those are your 2 options for that trinomial that comes out of a difference or sum of cubes. These are your options. Complete the square or quadratic formula. Let's complete the square for good practice. Bless you. First step to completing the square.
Minus 4.
Subtract 4 from both sides, leaving a little space. Then we needed the piece that I told you to memorize. Go ahead.
B over 2 squared.
B over 2 squared. B is 2, so 2 over 2 squared. That's 1 squared, so that's 1. What should I do with that 1?
Add it to both sides.
Add it to both sides. Okay. My right-hand side is just numbers. -4 plus 1 is -3. My left-hand side, the whole point of this is I wanted to factor into something squared. What number goes there? X plus 1, the number that I squared. Or you could say two numbers that multiply to 1 and add to 2. That's 1 and 1. Musa. Okay. Questions on how I completed the square there? Now we just solve it the rest of the way. I have something squared is equal to a number. How do I undo the square? Square root both sides, okay. I get x plus 1 is equal to, what's the square root of negative 3? I root 3, plus or minus, because we took the square root. My very last step, what do I need to do here? Subtract the 1. So negative 1 plus or minus I root 3. And that's my 1, 2, 3 solutions. If I were to graph this, which of these will show up as an x-intercept on my graph? Only the 2. Okay, on my graph, it's only going to look like I have one solution, one x-intercept. That's because this one's not shown, because it's imaginary. Okay, but we are eventually going to be graphing these things, so just keeping that in mind. This one does not show up as an intercept on our graph. Okay? Last one for just straight up factoring. This one has 4 terms. What's my method for factoring with 4 terms? Grouping. So group the first 2 and the second 2. Put a plus sign in between. Take a GCF out of your first group. 3x squared. You're left with 7x minus 2. And then from my second group, I just have to change the signs. What should I take out? A negative 1. Left with 7x minus 2. My parentheses match, so that is one of my factors. The 3x squared minus 1 is my other factor. Can either of these be factored more?
Yes.
Which one?
This 7x minus 2.
This one can't because we have a exponent of 1.
Oh.
So we're stuck. This one's almost a difference of squares, but that 3 is kind of messing us up. So we're stuck. We can't factor anymore. Next step is to set each factor equal to 0. So my 7x minus 2, I'm going to add the 2 over. Divide by 7. We get 2 7s. My 3x squared minus 1, I'm going to add the 1. Now what should I do? Not square root both sides. Not yet. Divide by 3 and then square root both sides. Okay. Remember, we can write square roots of a fraction as the square root of the top over the square root of the bottom. This is going to bring us back to what we did last unit. Go ahead.
Would it be wrong if we square rooted the whole thing?
No, like that's what I did here,
Okay.
but you wouldn't be done. You have to keep going. So if we look at this, what is the square root of 1? 1, so this is just plus or minus 1 over root 3. Should I just box in this answer and leave it?
No.
Why not?
You have to multiply by root 3.
Yeah, this root in the denominator is messing us up. So to get rid of it, we multiply by that root on top and bottom. That's from last unit. So now my final simplified answer, plus or minus, 1 times root 3 is just root 3. What's root 3 times root 3?
3.
3. So that's my 1, 2, 3 solutions. All of these ones would show up on our graph. This one would just be a really gross decimal. Brayden.
Does it matter if you leave the 1 there or not? For the
technically it's not simplified if you leave the 1, but I would not count off in this case. Any other questions on factoring? So you factor using however you know how to factor. Set your factors equal to 0. Sometimes we're also going to be given a factor. If you are given a factor, that's when we want to do synthetic division to factor it out. What are we looking for synthetic division to know that it worked? We need our remainder to be 0. So the next two that we do, we're going to be given a factor, and we're going to use synthetic division to kind of bump it down a level, a degree, and then we're going to keep factoring from there. Okay? So, this first one tells us x equals -3 is a 0. What is my special number in the box?
3.
-3. But my factor is when I switch my sign, x plus 3. So I'm really dividing here by x plus 3. But my 0 is -3. Okay. It says find all the zeros. What it's really asking is to solve the equation with that function set equal to 0. So we're solving this. To divide by x plus 3, I'm going to use synthetic division. So I need all of my coefficients on top. 1, 6, 11, and 6. And then I drop the baby mama. So I drop the 1. 1 times -3 is -3. Plus 6 is 3. Times -3 is -9. Plus 11 is 2. Times -3 is -6. And we get a 0 remainder. So that means it worked. I did it right because I got 0. And that also means that this equation can be turned into the factor that I took out, the x plus 3 factor, and what I got after I divided it out. If I started with an x cubed, this should be an x to what power? Squared. So x squared, x, and my constant. So x squared plus 3x plus 2. And now this is something more manageable. We started with an x cubed. I bumped it down a level by dividing out a factor. And now it's something squared, which I know how to work with. What should I do with these 3 terms right here? X method. Multiply to 2 and add to 3. 2 and 1. Can I just rewrite this as x plus 2, x plus 1? Yes, because a is 1 and my exponent is only 2. So we get x plus 3, don't lose that factor, times x plus 2 times x plus 1. Still equal to 0. Ava,
It's
good? Bless you. Now I have all these factors. What should I do with each of them? Set them equal to 0, aka switch the signs on all of those numbers. So we get -3, -2, and -1. Questions on that one? Again, we were given a factor, we divide it out, and then we deal with what's left. Okay. Next one's worded a little bit different, but it's the exact same kind of problem. It says find all the zeros of this function. So again, we're really setting this function equal to 0 and solving. Okay. And it says given that f of 1 equals 0 is a 0. What is x in this case? 1. X is 1. That relates to the 0, x equals 1. So what's my special number in the box? 1. And what's my factor?
X minus 1.
X minus 1. Okay, good. We're only ever really switching the sign when we're putting it in parentheses. Okay. I line up my coefficients on top. I start with 1. What comes next? 0. We have a 0x cubed. So still looking out for placeholders. 0. Then we have a 3x squared. And then another 0 for 0x. And then a negative 4. Okay, we drop the first one. And then we start multiplication, addition, multiplication, addition. The whole time we're just multiplying by 1. So whatever I get on the bottom row is just going to hop right over to the next column. So 1, 0 plus 1 is 1. 3 plus 1 is 4. 0 plus 4 is 4. Negative 4 times plus 4 is 0. So now I'm taking this function. I factored out our x minus 1. And I was left with, well, I started at an x to the 4th. So what should be here? X to the cubed, yeah. X cubed plus x squared plus 4x plus 4. Again, I started with something I could not deal with. Technically, we could have x methoded this. But I started with something I couldn't deal with. I bumped it down to something more manageable. How would I factor this 4-termed thing right here? Group. So here's my 2 groups. I'm going to kind of do 2 steps in one, but what GCF would I pull out of the first group? X squared. And I would be left with x plus 1. What should I take out of the second group to be left with x plus 1? 4. So we get x squared plus 4 as those GCFs that I took out. And then x plus 1 is my matching parentheses. Can either of these be factored more? Which ones?
The middle one?
We can't factor this one because it's a sum of squares, not a difference. That's okay. That means we're just going to set each factor equal to 0. So from the first one, we get 1, and from the last one, we get negative 1. So those are the 2 where we can just switch signs. And then this one, x squared plus 4. If I set that equal to 0 and subtract 4, I get x squared is equal to negative 4. We don't need to divide. How do we get the x squared away? Square root. Yeah, what's the square root of 4? Plus or minus 2i. Boom. That counts for your 1, 2, 3, 4 solutions. Questions on that one? So that's what we do if we can factor it or if we're given a 0. Sometimes you're not given a factor, like a 0, and you can't factor it manually. In Unit 2, we learned that we then have to guess and check with our P's and Q's. Where we would take the factors of our last term, put them over the factors of our first term, and guess and check all those numbers until we find one that works. We're still going to do that, but I don't need you to guess and check anymore. Few things. 1, on your test, you will not have to guess and check. I will give you something that can be factored, or I will give you a 0 to start with. However, we should know how to find zeros if we need to. So that can come from your P's and Q's if you guess and check, or it comes from your x-intercepts on your graph. So instead of guessing and checking P's and Q's, what we're going to do is we're going to graph it, and we're going to find the x-intercepts. I'm going to take one of my x-intercepts, and that'll be the special number in my box, okay? So on your homework, every single one of them you're going to have to graph. I'll show you 2 different ways to graph it, okay? But Just be aware it doesn't give you any zeros on your homework. You're going to have to graph it first. When we graph, you are only allowed to grab 1 0 off of that graph. You cannot just say, okay, I graphed it and I can see all of the zeros, so that's all of my answers. You will not get any credit, 0% on that homework assignment. Okay? You're allowed to grab 1 number off of your graph and then do the rest manually, just like what we did up here. Okay? So let's do an example of what that may look like. Raise your hand if you've looked at Desmos before. Hopefully all of us at Algebra 1. Perfect. For now, that's how I want you to graph. After Thanksgiving break, I'm going to teach you all how to use these calculators and the ones that I have in graphing on those. But for now, since you don't have these at home, let's use Desmos. So, this first one. Finding the zeros, aka solve this equation when it's set equal to 0. As a quick refresher, we could do our P over Q's, where we would take factors of 20. So that's 1 and 20, 2 and 10, and 4 and 5. And we put them over factors of our first term, so over 1. And these would be all the numbers that we would check. We would check 1 and -1, 2 and -2, 4 and -4. All of those until we find one that works. Instead of doing P's and Q's, we're going to go to Desmos. So in Desmos, if you haven't opened it up in a while, this is what, kind of what Desmos looks like. Hold on. This is what Desmos looks like. You'll have a little box up here. You can graph more than one thing at once, and then your graph will show up on the right. So if I just put this in, if I put in y is equal to, where are we, x cubed minus 8x squared plus 11x. So this is what you guys will have to do on your homework tonight, plus 11x plus 20. Okay. Eventually, yes, we will learn how to graph things that look like this, but for now, all we need to know is how to find the zeros. So your zeros are right here, and right here. Pick one that's a whole number if you can. So I can pick, if you click on it on Desmos, it'll tell you the actual point. -1 is one of my zeros, 4 and 5. So I can pick any of those 3 numbers to start with, but I can only pick one. If you just right here say x is equal to -1, 4, and 5, 0 points on your homework, okay? I give you permission to pick one. Let's pick -1. So, from my graph, I got x is equal to -1. I know my other 2 solutions, but I can't just pick them from my graph. I have to show them. So now I'm back in the exact same situation that I had right here. I now have a 0. I do synthetic division, and I find the other ones. We just added that extra step of looking at a graph to find that first 0, our starting point. So if x equals -1, what's my special number in the box? -1, and my factor is x plus 1. Okay. I line up my coefficients on the top. 1, -8, 11, and 20. I drop the 1. I'm just going to be changing the sign on all of those numbers that I dropped down. So -1, then -9, +9, 20, -20. So what I did is I took my cubic function, I pulled out an x plus 1, and I was left with this quadratic down here. I started with an x cubed. This gets bumped down to an x squared. So x squared minus 9x plus 20. The x plus 1 is good. What should I do with these 3 terms? What should I try? Yeah, try the x method. Multiply to 20, add to -9,
-4,
-4, -5. Can I just put those numbers right back in to my parentheses? Yeah. A is 1, and it's an x squared. So my final factored form is x plus 1, x minus 4, x minus 5. Now that I have all my factors, what should I do to each one of them? Set them equal to 0, aka change the sign. So final answer here, we get -1, +4, and +5. And if I look back at my graph, those were my zeros. Okay, but I have to show this work in between. You can only grab 1 0 at a time from your graph. Questions on that one? Okay. The next one, again, same thing. I have something that I can't factor because it's an odd number, and I'm not given any zeros, so I have to find one. So we're going to graph it and see what we get. So we open up Desmos or your graphing calculator or whatever. We type in our function. So 2x to the 4th plus 3x cubed plus 4x squared plus 9x minus 6.
Do we have the decimals on our chroma?
Yes, it's so Desmos, few different ways you can get to it. You can just look up Desmos graphing calculator, it'll show up. There's also, it's linked in the resources folder on Schoology, so you have like a direct link to it. And also, it's only taking me a while to type this in because I like don't have a keyboard, and I'm like typing it weird. It will not take you that long to type it in. But we type it in, and our graph looks like this. Right off the bat, how many x-intercepts do I have? 2. How many solutions, zeros, roots should I have? 4. I only have 2 real ones. That means my other 2 are imaginary. I have them. They're just not on my graph because they have an I in them. Okay? So I'm going to grab one of my zeros. Let's grab -2. Wissam.
Since they're imaginary, why are we writing them down?
They're imaginary numbers, complex numbers. They still exist.
What does that mean?
It just means there's an I. It means we can't graph them on the real Cartesian plane. We can graph them on the complex plane, which we don't get into in this class. It means we solved it and we were somehow taking the square root of a negative number. They're still numbers. They still exist. They're still solutions. We can still plug them in. They just don't show up on this graph because this graph is only over the real numbers. Did that answer your question? Okay. So from my graph, I got x equals -2. What's my special number? -2. And it goes with my factor, x plus 2. Okay, across the top, all of my coefficients. 2, 3, 4, 9, -6. Drop my first term. Multiplication, addition, multiplication, addition. So 2 times -2, -4. 3 minus 4 is -1. Times -2 is +2. Plus 4 is 6. -12. -3. +6, 0. I'm kind of speeding through the synthetic division, but if you don't get 0, that's how you know you need to stop and try again. Okay, so my original function, the thing that I graphed, turned into the 0 that I took out, so the x plus 2, times what was left down here. So this should be x to what power to start with?
To the 3rd.
To the 3rd. So 2x cubed minus x squared plus 6x minus 3. Okay. This one I can't mess with. It's just an x plus 2. This one has 4 terms. What should I try to do first? Group. So my first two groups, or my first two terms and my second two terms. Out of my first group, what's my GCF? X squared. Again, just going to kind of cut out that middle step. But if I took out an x squared, I would be left with a 2x minus 1. And then out of this group, I need to take out a positive 2 to be left with 2x minus 1. Okay.
Be positive 3.
Oh my gosh, that's the second time I've done that today. Positive 3, I'm left with 2x minus 1. Thank you. There we go. It's fixing. No, it's not. I just wrote down the wrong number again. This is still a 2. Our GCF out of the second group is a 3. Thank you. Okay. I have this entire thing factored. This middle term, or this middle factor, I can't touch because it's a plus sign. What should I do to each of my factors? Set them equal to 0. Okay, I'm changing the sign on my first one. We get negative 2. That's the first one that I grabbed from my graph. For this one, if I add the 1 and divide by 2, we get 1/2. That was also, if we look, on my graph. This is 1/2. If I press it, it'll show you. 1/2. Then my other 2 were imaginary, so whatever I get out of here is going to be imaginary. I would subtract my 3, and I would get x squared is equal to negative 3. Take the square root. What is the square root of negative 3? Plus or minus? I root 3. Perfect. So that's my other 2 that I can't see on my graph, but they are still solutions. Questions on that one? Okay, that's like the general idea. The bottom 2 that we're going to do get a little funky. So these ones might be the most important examples because these ones, things happen that we might not have seen before. Okay, so first step, I'm going to graph this. So if we graph it, this is 2x cubed plus x squared. Maybe. Minus 3x. Thank you. Minus 3x plus 1. Is that what you said? Plus 1? Yeah. Okay. That's what this graph looks like. We have 2 zeros here that we can see. Actually, we have more than that. There's multiple in this little gap right here. Do we all see how it goes under and then comes back up? So we have like 2 in here and 1 over here. Okay, this one is an ugly decimal. Don't use it. This means it's a square root somewhere. Okay? Don't use decimals that go on forever. Let's see what the other ones are. Ugly decimal, don't use it. Okay? Zooming in over here. Last one that we can see is 1/2. We wouldn't typically want to pick 1/2 because it's a fraction, and we don't want to deal with fractions unless we absolutely have to. In this case, we absolutely have to because the other ones are even longer, worse decimals. So the 0 that I'm grabbing from my graph is x is equal to 1/2. And here's where you have kind of some options after we get through the synthetic. This is what I was talking about earlier. So my special number is 1/2. If I put this back in as a factor, I need x times my denominator, so times 2, minus my numerator. This is the factor that I'm working with right here, 2x minus 1. I'll show you what happens if you forget that part, but we'll do that at the end. Okay. I line up my coefficients. 2, 1, -3, 1. Drop the 2. Multiplication, addition. Anytime we multiply by 1/2, we're really dividing this number by 2. So 2 divided by 2 is 1. 1 plus 1 is 2. Divided by 2 is 1. Minus 3 is -2. Then we get -1 and 0. When we went through this in Unit 2, since I had a fraction in my box, what did I have to do at the very, very end? Do you remember? We have to divide by my denominator. Divide by 2. We would get 1, 1, and -1. So I took my original function, and I said, okay, that's the same as 2x minus 1 times this piece right here. I started with an x cubed. This bumped me down to an x squared. So x squared plus x minus 1. Let's keep going. This first one is factored. This trinomial, are there two numbers that multiply to -1 and add to 1? No, so I can't factor it. What are my other two options? Completing the square. In this case, b is 1, which is odd. Do I really want to handle that 1/2 or 1/4 fraction that I'm going to have the whole time? No. So what's my best option for this? Quadratic formula. We are technically setting each factor equal to 0. We get 1/2 for the one on the left, and then we'll have to quadratic formula the one on the right. So we get x is equal to -b plus minus square root of b squared, so 1 squared, minus 4 times a times c. 4 times 1 times -1. All over 2a, 2 times 1. Okay. This would be 1 plus 4, so that's 5. So we get -1 plus or minus root 5 over 2. And that cannot be simplified anymore, so that is my solution. And if we plug this into the calculator, we get those same decimals that we saw on our graph. Brayden.
What if we divide by 2?
Anytime your special number in your box is a fraction, divide by whatever your fraction is dividing by. If you forget that, say you forget to divide by 2, no problem. You can also write your factor. Technically, most mathematicians won't do this. You would never do this in like a higher level math class. Saying it's okay for now, but you can also just write your normal x minus 1/2, and then you can leave these coefficients as they are without dividing off that 2. So 2x squared plus 2x minus 2. This is the same thing as this. They're equivalent. This one, you're just going to have that extra step of taking out a GCF before you factor. So I would recommend just writing it this way, but this will also work. Yes?
How did we go from x equals 1/2 to 2x minus 1?
Your denominator times x minus your numerator. So denominator times x minus your numerator. Any other questions on that one?
Divide by 2 because it's 1/2.
Yes. Divide by whatever your fraction's dividing by, whatever your denominator is. But you can't like mix the two. Like if you're going to divide your coefficients by 2, you have to use the 2x minus 1 factored form. If you're not going to divide your coefficients, then you have to use the x minus 1/2. Okay, you can't mix and match. Peter.
Can you go over like how you found how the x equals 1/2 again?
All I did was go to Desmos, graph it, and I picked where it crossed the x-axis.
Do you have to use those?
You'll have to use Desmos for every single homework problem today. Any other questions over that one? Okay, let's do one more. This one, again, something weird kind of happens, so just be aware. You could do your P's and Q's and guess and check, or what else can we do? If I don't want to guess and check my P's and Q's. Desmos, we graph. So I'm going to graph this one. Hop over to Desmos. We have x to the 4th.
Minus 3x.
You're awesome. Minus
3x cubed.
3x cubed.
Minus 15x squared.
Minus 15.
X squared plus 19x.
Plus what?
19x
Okay.
plus 30.
Okay. Let me zoom out a little bit. Here's your graph for this one. A little more complicated, but as you can see, we have 1, 2, 3, 4 x-intercepts. And our degree was 4. So we're not going to have any i's here. It's all on our picture. Technically, I know, just from my graph, my answers are going to be -3, -1, 2, and 5. I am only letting you grab one of your answers from the graph. The other ones you can check with your graph, but you need to show your work for how you got them. So, it's probably going to be easiest to do synthetic on my -1. So let's pick -1. From our graph, we got x is equal to -1. That's my special number in the box. What's the factor that goes with it? X plus 1. Okay. Line up your coefficients. So 1, -3, -15, 19, and 30. We're really just changing the sign. So synthetic isn't too bad. That's what you would get after you do synthetic division. So what I just did is I took my polynomial, I pulled out an x plus 1, and I was left with x cubed minus 4x squared minus 11x plus 30. Okay. The x plus 1 is done. How should I try to factor this 4-termed polynomial? Grouping. If I group this, will my parentheses ever match? No. Automatically doesn't work, okay? Can I use quadratic formula on this? No, because it's an x cubed, and we don't have a formula that works for an x cubed. So I can't factor, and I don't know any zeros. So, just like what we did here, we couldn't factor, we didn't know any zeros, we have to graph it again. But now we're graphing just this x cubed portion. My zeros are going to come out the same, but I'm going to re-put it into my graph. So, again, from my graph, I'm just going to put in my new, more simple cubic function. So, that is, maybe, where am I? X cubed minus 4x squared minus 11x plus 30, yes. Okay. And if you look, this is a very, very similar graph to what we started with, but that factor that I divided off, my -1, is gone because it was part of my x to the 4th, but I divided it off and it's not part of my x cubed. But for my x cubed, I have -3, 2, and 5. You pick one. This is like one of those times where we're technically grabbing more than one zero from our graph, but the only reason we did that is because we had to graph this one again. So from our graph, let's just say I picked up my x equals 2. We do synthetic. Again, synthetic on this new, more simple function. So if I fill out my coefficients, that is 1, -4, -11, and 30. I drop the 1. Times 2 is 2. Minus 4 is -2. Times 2, -4. Minus 11, -15. Then -30. And we get our 0 remainder. Key here is we then took this and we took an x minus 2 out of this. So we still have that first factor that we divided off. We still have the x plus 1. We have the x minus 2 that we just divided off. And we have what's left right here. Our x squared minus 2x minus 15. Yeah, go ahead, Ava.
Can we, along the way, when we already know we're gonna take the x minus 2 as a factor thing, can we already do x equals 2?
Yeah, if you don't want to write these factors, that's fine. You can just set them equal to 0 right when you find them.
And like box them and then keep them?
Yeah, and then just be done. That works. I just like to follow it all the way down because some questions might just ask you to factor, and then you already have it in factored form at the very end, you know? But my first 2 sets of parentheses are good. What should I do with this last piece? X method, 2 numbers that multiply to -15 and add to -2. -5 and 3. We can just put them right back in as factors. Last step is setting all of these equal to 0. We would get -1, +2, +5, -3. And if we remember, those are the 4 zeros that I had on my original graph, my x to the 4th graph. Questions about today's stuff? So again, if you can factor it, factor it. If you're given a 0, do synthetic. If you're not, then graph it, do synthetic, and then factor quadratic formula or do synthetic again.
If I like graph it and it's all like a thing, do I really need to like,
Yes, you will get a 0% if you don't.
okay.
Yeah, so if you graph it and you know that all of your zeros are there, it's a great way to check, but you're not going to get any credit if you just write down the answers. That being said, on like your test, you're not going to have to graph any because it's going to be a baby calculator test, so you won't be able to graph any. And I'll just give you a 0. So that's why I want you to practice even with the graphs going through the whole process. Okay? Okay, there are